Okay, hello Calc 2. In this lesson I want to look at this idea called slope fields. And you're getting a differential equation, an equation that has derivatives in it, and it may have x's and y's and things of that nature, and you'd like to find the solution. So your solution oftentimes is y equals whatever. Okay, that's your solution. Sometimes differential equations are maybe difficult to solve depending on the way they're set up. But this slope field idea is relatively simple. Now, it is made for first order differential equations, which means you have the first derivative. So for y prime, so y prime is your first derivative. If it is an expression in x and y, and that's what all this means here, so it's a function of x and y, we can find the slope at, let me move this up here a little bit, so we can find the slope at certain points. Okay, so x and y values determine points in a coordinate plane, and we know that the slope is related to x's and y's. So what we'll be able to do is get a graphical way of looking at a solution to a differential equation problem if it's first order. All right. So the idea is this: if we draw little short line segments that show the slope at various values of x and y, or points, then we can create the slope field and give us kind of an idea what the shape of the solution may look like, what the y equals may look like. All right, it's also called direction fields too. All right, so let me find my cursor. There it is. Slope fields show the general shape of all these solutions for the differential equation. So let's look at an example, and I'm also going to use a couple of graphical, a graphical approach with the GeoGebra, and there's a differential equations calculator that we can use to kind of verify that we're on the right track. So here's the first problem. We're going to sketch a slope field for the differential equation, and this is what it looks like. Y prime is equal to x plus y. So that's our differential equation. First derivative is equal to x plus y. What we want to get here is a kind of the graph of the solutions to this differential equation. And then we'll want to get the graph of a solution that has to go through a certain point. So this would be more of a specific solution because it's going through this point. All right, the slope field will give you like all the solutions, but we want the specific one also. So here's the deal. We're going to pick various x's and y's, graph them in the coordinate plane, and then take the x coordinate plus the y coordinate. If you add those up, that has to be equivalent to the slope. So we'll make a little line segment with the proper slope at the points, and we'll do that for multiple points and see what it all looks like. All right, so I already have it sketched out down here, but let me kind of talk our way through that, because what you would have is just a regular y and x axis, and you could label them, like 0, 1, 2, 3, 4, and so on, negative 1, 2, 3, and negative 4 in the x and in the y direction. And then pick points and sketch out what you think the slope would be at the little line segment. So let's start with, what if I look at the point 0, 0, right at the origin? So forget all the things that I have on here except for the x and y axis, and we'll talk our way through creating it. So if I'm at the origin, x is 0, y is 0. So go up here, x would be 0, y is 0, 0 plus 0 is 0, y prime, which is the slope would be 0. So at this origin, I would say, oh, the slope is 0. So I make a little line segment that's horizontal. All right? Let's go up the y-axis. So if I go to the next point right here, I'm at the point 0 for x, 1 for y. 0 for x plus 1 for y gives me 1. 0 plus 1 is 1. I would, at that point, have a slope of 1. So I'm at this point here. I'm going to do a little line segment that looks like about a slope of 1. Well, if I move right up to the next one right above it, that would be 0, 2. 0 for x plus 2 for y. Add them together, you get 2. So at that point, if I have a solution going through that point, it would have to have a slope of 2. So here I make it a slope of about 2. It's steeper than a slope of 1. Well, as you continue to go straight up, all you're doing is adding 1 because y is going up by 1. So I started with the slope of 0 right here, go up here to slope of 1, 2, 3, 4, and so I get all those type of things there. If I go down below on the y-axis, below the origin, I would have the point 0, negative 1. You can see that would have a slope of negative 1 because 0 plus negative 1 is negative 1. So I can get some negative slopes too. All right. I'm just going to pick a couple other points. Let me go like along the positive x-axis right now. So if I go to the point 1, 0, x is 1, y is 0, 1 plus 0 is still 1, the slope is 1. So I have the slope of 1 here. If I move to the point 2, 0, all I've done is make x 1 more. Y didn't change, so now I have a slope of 2, move on out to here, a slope of 3, and a slope of 4. So it's getting steeper and steeper and steeper. Let me move to the point negative 1, 0. X is negative 1, x is negative 1, y is 0. Negative 1 plus 0 is negative 1. The slope would be negative 1. All right? And then just move to some other points. So let's look at this point here. Because what you'd want to do is to do enough of these in a certain area that you can kind of see the flow of the slopes. And so you're going to have a curve that's going to go through these things. So if we want to find the solution that goes through the point 2, 1, 2 comma 1, and I go to the point 1, 2, up 1, I have this point right here. Well, the slope has to be, in this case, x is 2, y is 1, 2 plus 1 is 3, so it's got a slope of 3. All right? And if I do enough other points around here and then look at the path that the solution must go through, if it's going to go through this point 2, 1, I sort of sketch out looking at the slopes, and it looks like something like this. Not necessarily a parabola, but kind of a concave up-looking type thing if it goes through this point. Now, if it has to go through different points, the shape can change a little bit. So that's kind of the idea behind a slope field. Now, what I want to do here is grab, there is a slope field kind of grapher in GeoGebra, which I will share with you. I'm going to go get it right now. We're going to do the same exact problem, but kind of verify that our kind of, this is sort of red, solution looks appropriate. So let me go into GeoGebra. And here's what it would be in GeoGebra. Now, this is just already created. So I'm going to go up here to the upper left corner. You can see f prime of x, y. So that's really your y prime. It's the same as your y prime. It's your first derivative. So y prime equals, and this one's already set up for x minus y. So I'm going to change it. I'm going to click in the little box, and I'm going to make that x, if it lets me. There we go. X plus y. And then I'll hit enter. So it changed it to the differential equations problem that we're looking at here. And you can see all the different slope field line segments that are on here. Now, this green line, or this green curve, is generated if you want to go through the point negative 3, 3. So I'm going to grab that point and move it to the one that we were dealing with in that prior problem, which was the point 2, 1. So I'm just going to click hold, drag it until I get to the point 2, 1. So look at what it's doing. It's finding all these slope segments, and it's generating a graph that would eventually go through the point 2, 1 by just looking at the slope. So you can kind of see the slope It's like almost like a weather pattern look to it. And it generates that one. But as I move it around, like if I were to say, okay, what's the solution to the differential equation look like if it's going through, say, another point? So let me move it down into here. It just changes. If I move it down into here, it might do something like that. You know, you can kind of see what's going on as you move it to different places. It's picking a graphical solution. I'll put it right back to here. All right, now, what if we wanted to take this and sort of verify that in another way that this is what you would get? I'm going to go to the differential equations calculator. So I shared this with you last week. Let me go into that. And I'm going to put the problem in right here. Okay? So let me erase all this stuff. And there's our y prime equals x plus y. And then I'm going to put in a comma, and I'm going to put in the point. The point is the point 2, 1. Now, the way I'll do that is I'll say y when x is 2 is equal to a value of 1. All right, that's just the way that you put it in for this calculator. So I'm going to hit return. I think I did. Try it again. Let's see if it took that. Oh, there it goes. All right, so it's generating a solution. All right. All right, so it wrote it really weird here, but it knows that, like if I added y to both sides here, it would say that y prime is equal to x plus y. And here's what it gives us for a solution. All right, it says that y equals negative x plus 4e to the x minus 2 power minus 1. All right, I'm going to take that and graph this in Desmos now. Okay, so now I'm in Desmos, and I took the solution equation to the differential equation from that differential equations calculator, and I just put it into here, and here we get exactly what that shape would look like there. So you can see the slope field sort of does that for you. You have to kind of draw it in yourself. If you go to the GeoGebra slope field thing, it's pretty nice. You know, you just find the point that you want the solution to go through, and it will trace it all out for you. But I'm just verifying it using the differential equations calculator, and then taking whatever they say the solution would be and putting it into Desmos. So that's what you got. Now, last thing here is, and you can kind of do this one probably on your own to see if that's what you would get. Here's the second problem. And the only difference here is you have a different differential equation. So my differential equation is y prime equals x minus 2y. You'd still do the same type of thing. You would pick a bunch of different, let me move me out of the way there, pick a bunch of different points, x and y points, plug them in to find the slope, generate your little slope segments here, and then if you want it to go through the point 1, negative 2, sort of trace it out, and it should look something like this. So I hope this helps a little bit on slope fields, and if we need to, we'll talk about it a little bit more. All right?